Hello everyone, my name is Harsh Vinod Masne. My SAP ID is 600011980004. Today I am going to present my first DLIC practical, which is design of an inverting and non-inverting amplifier. So I am going to design it on Esim software. So before starting, let's see some of the features of the Esim software. So Esim is an open and free source EDA software which is developed by Fossis team at IIT Bombay. It is an integrated tool built by using KiCad, ngSpice and GSDL. So it runs on Linux OS, Windows OS as well as Ubuntu OS. It provides three main features, that is create circuit schematic, circuit simulation and also create a PCB layout. It has a large number of circuit simulations examples in it provided already. Besides this, Esim team has also created some of the spoken tutorials for self-learning. So when we open the Esim software, this is the first window pop-ups. Then, so before starting, let's see the basic of the inverting amplifier. So inverting amplifier, we connect our we give input signal to the inverting terminal and non-inverting terminal is grounded and provide a feedback with the RF resistor. So here the output is 180 degree out of phase with respect to the input. So where VO is equal to minus RF by Rin times the Vin, and the gain of the circuit is dependent on the resistor RF by Rin. So let's design this circuit on the Esim software. So first of all, we have to click on new project, enter the file name. Okay. Then click on open schematic. Click on yes. Then place the components, here the place component. I am using Lm741IC. Okay, place it here. Then we'll take some of the resistors. Okay, so we'll require total 3 resistors. So let's place it where we want it, and the RL. By clicking R, we can rotate the resistors. Okay, then we'll require a DC supply to power the op amp. We'll basically require 2 supplies, that is positive 15 volt and negative 15 volt. Okay. Then we'll take the plot V1, which will require to plot the input and output voltage. So total will take 2, one at output side and one at input side. Okay, and then we'll require a sine wave supply, which is the AC signal. We'll connect it here. Okay, let's move the resistor. Okay, so will do the wiring of it. So here, for that, let's move the resistor a little bit up. Okay. We can also zoom it to see the proper connections. Okay, this will go to the ground and wire, connect the plot. This will go to the output. Okay, and wire, connect it. This will go to the RL and wire. And wire, okay. Okay, now we will connect the supply. As I am connecting it together, so we'll require a PWR flag, as there will be no errors. Now, okay, this connect here. Take here also. Anyway, so we'll take a label for output. Rotate it, connect it with here, and then label it. It's a global label. Put. Okay, and then connect here. We'll take ground. One ground here. Let's copy it. One will be here, and one at a non-inverting terminal. Okay, we connect the positive and negative supply. This will be my positive supply, and this will go to the negative supply. Okay, so let's give the naming. This will be my 5K. Sometimes it gets hanged, so yes. Then RL, this is my RL. Okay, this is my RF. This is my R1. This is my V1 supply. Will be my V2 supply. This will be my V3 supply. Okay, then this will be my U2 plot. This will be my U1. Okay, bit. Okay, nothing left. Let's see. Okay, so to provide a supply. This will be my plus 15 volt. Minus 15 volt. Okay, now we'll change the resistor value. So here I will take gain of 2. So we'll take RF of 2 kilo ohm. Okay, and R2 will be my 1 kilo. Okay, so now let's see. Okay, so let's annotate it. So we have to click on annotate. Okay, check for errors. It also provides for checking error. Let's see. Okay, ignore the global errors. See if any connection is left. We don't require offset nullification, so no required of connecting a offset compensating network. Okay, close. Then we have to click on generate netlist, spice, default format, save it. Okay, click on save here also. Nothing else to do. Okay, let's see how our circuit works, how it works. Okay, so then come on the main window, click on keycad to ngSpice. Transient state will give a start time of 0 millisecond. Step time will be our 100 microsecond. And stop time will be our 100 millisecond. Then offset will be 0. Let's go for 4 volt peak to peak, 50 hertz, 0, 0. Okay, then we add a sub circuit. We have to provide a sub circuit which we are using the IC. So Lm741, select, convert it. Okay, now let's click on simulation. Okay, let's see it on Python plot. Output, input label, and plot it. As you can see, the blue color waveform is an input, which is 4 volts peak to peak, and the purple one is a output, which is a 8 volt peak to peak. So gain of 2 and an input of 2 and an input of 4 becomes 8 volt. You can see it. Okay, let's now change the gain value and see how the waveform gets clipped when it crosses the plus V and minus V saturation voltage. Let's see how it goes into saturation. So let's change the RF value. We'll take a 5k, so our gain will be 5. Okay, again annotate. Okay, we have checked the errors. No, don't require. Default generate, save it. Again, let's save it. We'll close this all. Again, step time, stop time, same. We'll give a source now. Let's go for 6 volts, peak to peak, and sub-circuit convert. Okay, let's do the simulation. Okay, Python plot, input output, and plot it. As you can see, the voltage gets clipped at around 14 volt, approx 14 volts at positive side as well as at negative side. And there is a phase shift also of 180 degree. You can see the input is sine, the output is cosine wave. So now let's go for non-inverting amplifier. Before that, let's see the basics of the non-inverting amplifier. So in non-inverting amplifier, we provide an input signal to the non-inverting terminal of an op-amp, and then inverting terminal is grounded. Similarly, we will provide a negative feedback with the help of RF resistor. So here the output will be the amplified output signal with in phase bud. So here VO is equal to 1 plus RF by R2 times the Vin, and the gain of the circuit will be 1 plus RF by R2. I have already designed the non-inverting amplifier, so let's open it. Select folder. Okay, we'll close this now. So this is my non-inverting amplifier. You can see the inverting terminal is grounded, and the non-inverting terminal we have provided the input signal, and similarly plus volt, minus 15 volt output. Okay, so we will change it. So let's change the gain to the 2. Take here 1k. Okay, we'll annotate. Okay, and already check the errors. Default, generate, save it. Again, click on save. Then go to the main window. Click add to ngSpice. Again, the same. Will source provider 4 volts peak to peak, same 50 hertz. Add a sub circuit, convert it. Let's see the simulation. Similarly, you can see the output is of 8 volts peak to peak, and input is 4 volts peak to peak. You can see it on Python plot. Okay, so you can see it is in phase with the increase in the output, which is 8 volt peak to peak, and the input is 4 volts peak to peak. So now similarly we'll see for the clipping of the output signal. So let's change the RF value. We'll keep a 4k, which will become a total of gain 5. Okay. Save it. So annotate, generate, save it. So let's go for again the 6 volt peak to peak, convert. Okay, so now simulate it. Let's simulate and see the clipped wave. Let's see on Python plot. It's easy to understand it. So you can see the clipped plus at around plus 14 volts and the minus 14 volts approx, and the input signal of 6 volt peak to peak. Okay, so this is our end of the video. Thanks for watching.